All right, ladies and gents, let's get into this next one. So this, I think, should be the proof that is across some same side interior angles. So this is, let's go ahead and match it. So this is one of the proofs where we start to see a little bit more algebra involved. And so we have to start kind of shifting our thinking. Because if you notice here, the proof statement does not actually ask you to prove triangles are congruent or sides are congruent or angles are congruent. It asks you essentially to build an equation. And so again, this is going to be another type of proof. We just have to kind of be adaptive and skillful in how we approach this. But again, you're going to notice just a different thing. And so the mentality I want you to have is, in the end, they want us to show an equation exists. The measurement of angle 1 plus a measurement of angle 2 plus a measurement of angle 3 is equal to 180 degrees. In other words, they want you to prove that if we have this triangle, which I'm going to go ahead and highlight in blue, the angles of a triangle add to 180 degrees. Now you may be thinking, Mr. Collins, I know that actually is true. We've been using that as a fact, not just in this class, but like really in math for years. Why do we have to prove it to be true? Well, in mathematics, nothing is true unless you can show it's objectively true through proof. And so the trick here is that we actually have to prove the triangle sum theorem exists without using the triangle sum theorem. And so it's not fair to say, oh, the blue thing is a triangle, therefore the angles add to 180. We have to show they add to 180 indirectly without ever actually using that particular fact. Now, I know that's kind of nuts, but you're going to see that theme repeated several times throughout these proofs, where we have something that we say is absolutely true, like the angles of a triangle add to 180 degrees, but we have to prove it without actually using that particular fact. The thing that you've experienced that's like this is that you can't define a word using the word itself. Like if I said, hey, please define the word tree, the one word you cannot use is tree. And so if we want to prove this fact is true, the one fact we cannot use is that the angles of a triangle add to 180 degrees. Either way, I digress. Let's get into the analysis, and hopefully this will become a little bit more clear as we kind of progress through this proof. And again, the analysis is really just designed to help us like understand the information we have to work with and start generating new information that can help us get closer to our goal, which in this case is to build this equation. Okay. All right, so let's get into it. So the only thing we have to go on is that we have two lines that are parallel. We have line M and we have line N are parallel. So I'll kind of highlight those a little bit in this thin blue line. So we're told they're parallel, so I'm going to mark them to be parallel. That doesn't seem to be a lot of information to go on, but if you start developing this mentality that as soon as you hear parallel lines, you know that you have angles of some kind, then we're actually in business. Now we should also note that since we have to we have to build the equation angle 1 plus angle 2 plus angle 3 equals 180, we kind of have to start with an equation that has some of that information already, that has 1, 2, and 3 involved. And so for me, I'm looking right here. I'm looking at angle 1, and I'm looking at angle 2 and 5 together as a group. Because if I have two lines cut by a transversal, and I'm going to take this line right here, line K, to be my transversal, these angles should have a relationship. The angle at 1 and the angle if I combine 2 and 5 together, notice they're on the same side of the transversal, they're on the right, and they're in between the two lines. And so they're going to be same side interior angles. Okay, so it's same side interior angles. Okay, and so if you recall from your notes, same side interior angles are not congruent. They're actually going to be supplementary. In other words, if I take the measurement of angle 1, and then I add the measurement of angle 2 plus the measurement of angle 5, in other words, I add those together, I should end up with 180 degrees. Now, this is a really interesting starting point because if you look at the equation I have to build, okay, the one up here that I've already highlighted in orange like 6 or 7 times, this has 1 plus 2 plus 3 equals 180. Well, if you look at the equation that I know is true right now, I am so darn close to it. I have angle 1 plus angle 2 plus angle 5 is 180. And so really, my thinking is, if I can just somehow replace angle 5 with angle 3, I have our equation built. Well, angle 3 is right here. Angle 3 is this guy right here. Now that doesn't belong to the same transversal. It belongs to, let's use pink. It belongs to this transversal right here. If I use the same two parallel lines, but then I look at angle 3, that has a relationship with angle 5, because angle 5 is also attached to the same transversal. Okay, so if I look at angle 5 and look at angle 3, those are going to be alternate interior angles. Now again, if you can't see that, a good tactic would be to redraw them. So here are the two lines, M and N. Here's the, actually it should be pink. Here's the pink transversal. And so angle 5 is right here, angle 3 is right there. And so those are definitely inside the lines on either side of the transversal. And so those are alternate interior angles. Okay, and so we have this equation that we started with. Let me star it or do something with it. Okay, so we have this equation that we started with, and then we have alternate interior angles. And if I recall alternate interior angles, they should be congruent. And so I know that the measurement of angle 3 should be the same as the measurement of angle 5 because alternate interior angles are congruent. Well, look, if I have 1 plus 2 plus 5, and I know 3 and 5 are the same, that means I can just take 3 and I can substitute it in. Okay? So it seems like the pathway here is not going to be a triangle congruency shortcut, but rather building an equation. And so the way I think we're going to do this is we're going to start with this equation that we're given because of same side interior angles. We're going to find a substitution. So we're going to find that 3 and 5 are the same, and then we can substitute 3 for 5, measure angle 3 for the measure of angle 5, and then we're going to have an equation that says 1 plus 2 plus 3 equals 180, which is precisely what we're being asked to prove up here. Okay? So a little bit different in terms of how this is being built, but our statement of intent, let's move some of that. But our statement of intent, I guess I could just erase that part, is going to be exactly as described. So to prove the three angles added together make 180 degrees, I'll start with an equation given by same side interior angles, that's this guy right here, and then use alternate interior angles, which are the 5 and the 3, and then do a little substitution to build the final equation that I'm being asked to prove. And so the style of this proof writing I think is got to be a little different. I'm not going to use a flow style proof for this. Instead I think I'm going to use a 2-column proof. And 2-column proofs I think lend themselves a little better to this kind of thinking because it's a little bit more step by step. Okay, so let's set up our 2-column proof, and we might have to spill over to the other side. On the left hand side, we're going to give our statements. On the right hand side, we'll give our justifications. Okay, and so let's get into the writing of it. Now the first thing we should do though, before we do anything else, is state our givens, and that's kind of like our step 0. And so our givens here is that we have 2 parallel lines. It was actually given to us right here. Line M is parallel to line N. And so that's like initializing your variables in physics. You just have to kind of state the starting conditions before you write the proof. Now the justification here is straightforward. It was simply given to us, and I do apologize for my handwriting. I know it's not very good. Okay, so let's get into the writing part of this then. Okay, so as our first step, we need to start with the equation. And so it says right here, I'm going to start with the equation given by same side interior angles. And so the same side interior angle equation is right here. It was using angle 2 and 5 and angle 1, noticing that they're supplementary. Okay, and so that's what we can write. So the measurement of angle 1 plus the measurement of angle 2 plus the measurement of angle 5 is equal to 180 degrees. And that's going to be because of same side interior angles. Okay. And then we have to create an exchange, a substitution, because I don't want to say 1 plus 2 plus 5 equals 180. I wanted to say 1 plus 2 plus 3 equals 180. But here we can make a shift because we know angle 5 and angle 3 are congruent, and we know that they're congruent because of alternate interior angles. Okay, so our second statement is that the measurement of angle 3 should be equal, that's an equal sign, measure angle 5. And the reason for that is because of alternate interior angles. Okay, and that's why this first statement is so important, because alternate interior angles, same side interior angles just have this relationship only because the lines are parallel. Okay, now we have one last thing we need to do is do a substitution. Because if we have 3 and 5 that are the same, we can take out 5 and put in 3 in its place. And so our final statement should say the measurement of angle 1 plus a measurement of angle 2 plus a measurement of angle 3 is equal to 180. Let's see if I can squeeze that in there. Oh, yeah, we can. Okay, and we're going to do this by substitution. Okay, and recall substitution and transition are just extras. It's something that we added quite recently, but that gives us a justification to take out one thing. In other words, we're going to take out this 5. Okay, so we're taking out the 5, and we're replacing the 5 with an angle 3 because we know that 5 and 3 are exchangeable. They're equivalent. Okay? And so we're actually done with the proof. As soon as we hit this step, where we show that the measurement of angle 1 plus a measurement of angle 2 plus a measurement of angle 3, let's see if I can rewrite that, that's not very good, equals 180 degrees. Okay? We are finished because that's exactly what we're being asked to prove. We're being asked to build this equation, and we just did. And so definitely a different kind of proof than what we've written in the past, but this is another type of proof that you're responsible for being able to do. So sometimes you'll have to prove triangles are congruent, sometimes you'll have to build equations using a little bit of algebra. And so we saw a little bit of that, well, I'm sorry, we haven't seen too much of that yet, but you're going to see that as a theme kind of moving forward, all right? So that's going to be this whole proof. All right, thank you, and I'll see you in the next vid.